Welcome to this explainer. We are literally living in a defining era of human history right now. Traveling to the moon, that was once this huge, wild fantasy. But today, it's just a completed chapter in our history books. We conquered it. So what exactly is humanity's next massive dream? Mars. We're moving entirely out of the realm of science fiction and into an active, tangible goal. We are talking about building actual, living human settlements on the red planet.
Okay, let's dive into this. Does Earth really need a backup planet? You might be wondering, why pour billions of dollars and dedicate our absolute brightest minds to the stars when we have a perfectly good home right here? Well, it ultimately comes down to the fragility of our existence. We really have to ask ourselves if putting all of humanity's eggs into one planetary basket is a mathematically sound, sustainable strategy for the long-term survival of our species.
Because the reality is, we're facing an unprecedented barrage of existential threats. Just think about it. Climate change rapidly altering our environment, the constant looming threat of nuclear war, global viruses and pandemics, skyrocketing overpopulation, and totally unpredictable catastrophic natural disasters. The scientific consensus is growing louder by the day. If humanity is going to survive in the long term, our civilization simply cannot remain limited to a single point of failure. We need a contingency plan. We absolutely need a second home.
So why Mars, right? It's certainly not a perfect Earth replica, but it offers the absolute best foundational starting point in our entire solar system. The day lengths closely match our own circadian rhythms, it has manageable changing seasons, and there's enough gravity to actually anchor us. But critically, we know that ice water reserves exist there, and scientists believe these can be leveraged for future farming and even synthesized into rocket fuel. It's just the logical baseline for human expansion.
Now, the immediate benefit of this massive quest is the incredible leap it forces in our own technology. Solving for Mars pushes earthly innovation into absolute overdrive. We're triggering rapid advancements in robotics, AI systems, space medicine, entirely new energy grids, and hyper-efficient water recycling. And remember, everyday staples you rely on right now, things like the GPS in your phone and satellite internet, well, those were born directly from earlier space research. Reaching for Mars dramatically elevates what we can do right here on Earth.
But actually, let's hold on a second. Let's take a collective breath and step back from the romanticized sci-fi illusions of space travel. Is living on Mars going to be easy? No. It is extremely difficult. In fact, it will be one of the most punishing, demanding challenges we have ever faced. We really need to strip away that cinematic fantasy and look at the incredibly harsh realities and massive engineering constraints of this environment.
And this brilliantly illustrates our first massive hurdle. At 95% carbon dioxide, the oxygen levels on Mars are practically zero. A human cannot survive even a few seconds on the surface without being completely, highly pressurized in a spacesuit. There is simply no breathable air. You step outside unprotected, and it's game over immediately. So we aren't just building houses, we are building hyper-resilient pressure vessels just to survive a quick walk outside. And if the lack of oxygen doesn't scare you, the extreme thermal conditions absolutely should. Mars sits at an average of negative 60 degrees Celsius, but it plunges to a terrifying, brutal negative 125 degrees in certain regions. To put that into perspective, this isn't just dangerous to our biology, it presents a massive, relentless thermal engineering nightmare for our habitats, our rovers, and all our machinery. Metals become brittle, lubricants freeze solid, and just keeping humans alive and warm requires an enormous, uninterrupted power supply.
Then there is the invisible killer. Unlike Earth, Mars lacks a strong magnetic field. That means solar and cosmic radiation strike the planet and anyone on it directly. Long-term exposure without immense shielding guarantees severe, life-threatening health issues. We're talking massive cancer risks, fundamental DNA damage, and serious cognitive and brain problems. Our habitats are going to require absolutely flawless architectural solutions. This might even force us to build our first colonies deep underground or encased in meters of Martian soil, just to block out that radiation.
And to compound all of this, we have the weather. But we aren't dealing with a little rain. We're dealing with massive, planet-wide dust storms that can last for weeks or even months at a time. They completely ruin visibility, but much more critically, they block out our solar panels. That literally strangles the power supply needed to run those vital heaters, fighting off that negative 125-degree cold. Plus, that fine, abrasive dust can easily infiltrate and destroy crucial life-saving equipment.
So with absolutely no breathable air, freezing temperatures, deadly radiation, and month-long dust storms, how do we systematically survive? Well, we engineer a closed-loop ecosystem completely from scratch. We have to master what's called in situ resource utilization.
Because remember, there are no supermarkets on Mars, no rivers, and no normal soil. That means highly advanced indoor farming, zero-waste water recycling systems where literally not a single drop is lost, and complex artificial food production. We literally have to bring and indefinitely sustain our own entire biosphere.
So, who is actually brave enough to take this on? Well, we are rapidly moving from conceptual dreams to active, funded reality. We've got public heavyweights like NASA and the European Space Agency laying the absolutely crucial scientific groundwork. And they are working right alongside aggressive private entities like SpaceX and Blue Origin, who are building the massive, reusable rockets required for this interplanetary transport. It's truly a combined, global effort from the absolute brightest engineering minds on Earth.
So, the crucial point is the sheer, unbelievable scale of this vision. This isn't just some Apollo-style flags and footprints mission where we visit for a few days and come right back. As Elon Musk has stated, the goal is literally a city with millions of people living on Mars. They are aiming to establish an entirely new branch of human civilization. We're talking about a self-sustaining, permanent, bustling metropolis on a completely alien world. It's undeniably the most ambitious engineering project ever conceived by humanity.
But all of this monumental effort raises a really important, poignant question. If we pour our hearts, our technology, and our future into colonizing the stars, will humans forget Earth by living on Mars? Will we abandon our first home in pursuit of our second? I think it's a perfectly fair, emotional question to ask when we look at the billions of dollars and the immense resources being spent just to leave our atmosphere.
Well, the answer is a resounding no. The truest realization of all these ambitious space projects is actually a renewed perspective. Learning about the deadly cold, the radiation, and the total lack of air on Mars actually reminds us just how incredibly valuable and perfect Earth truly is. It is the absolute best home we've ever found for life. But human curiosity is what turns the impossible into reality. Things like airplanes and the internet were once completely impossible, right? So I want to leave you with this provocative thought. How long do you think it will be before the next chapter of human history is written not here on Earth, but in the red dust of Mars?